Okay, what are these applications? Just list me the applications. We'll see diode as a rectifier. Second application we see diode clipping circuits. Of course, the model we will discuss. Two models for remaining clipping circuits. Okay, then clamper circuits. Then you have a Zener diode. Zener diode as a voltage regulator. Then you have fifth applications. You have a diodes as a logic gates. Okay, so fabrication of logic gates. Okay, so fabrication, not fabrication. Okay, implementation, implement implementing implementation of logic gates using diodes. And then we'll see voltage multiplier circuits, voltage multiplier circuits. And the last we'll see how to deal with diode for AC, for small signal AC source. Okay, so small signal AC analysis of diode, small signal AC analysis. Okay, here we will discuss DC and AC resistance of diode. AC resistance. So these are the some applications which we are going to discuss. Now we'll take each application at a time and then we will continue. Students are not joining. Okay. So let us start now the application number 1, diode as a rectifier. Can I erase this one? The first application is diode as a rectifier. Okay. Let us start with a half wave rectifier. Half wave rectifier. Now say you have a source. Okay. It's a AC source. Or time dependent source. Here you have a diode and here you have a resistance RL, load, where you're taking the voltage, and this is your, here you are measuring the output like this. Like this, your multimeter is kept. So we are measuring the voltage of this point with respect to this point. So now this is the V input, and V input is your Vm sine omega t. Okay. Now the diode is ideal diode. We are considering so far, we'll consider ideal diode case only. So ideal diode, whenever it is forward bias, it will be replaced by a short circuit. And if it is a reverse bias, it will be like open, or it will be like your open circuit. So this is my input. This is my V input, which is a sine wave. Which is a sine wave of magnitude is Vm, maximum magnitude is maximum value, okay, is Vm, this is V input. And here, now this is the positive cycle and this is the negative cycle. So whenever there is a positive cycle, this diode will be will be short circuited, okay. So for positive cycle, okay, diode is short circuit, diode is short circuit. That means the voltage drop here Vd is 0. So your V naught will be what? V naught will be equal to V input. Yes or no? And V input is this one. So for positive cycle, when this positive cycle coming, your V output will be exactly like your V input. So this is your V output. It will be same like your V input. Nothing changed. Okay. And when you are applying what where you are applying negative cycle, for negative cycle, okay, this diode will become open. Diode is open, so no current can flow. Negative cycle, always you remember, negative cycle means now this part, the positive cycle, this part is positive, this part is negative. Negative cycle, what will happen? Current will flow opposite way. This part will become positive, this become negative. And this diode will now, because of this voltage, this diode will become now a reverse bias. So you can make it open. So when open is there, there is a no current in the load. No current in the load means your V output will be 0. So your V output will be 0. So here for negative cycle, you will not get any output in the load resistance. So this is your half wave rectifier. So that's why we say that.
सर
Tell me.
सर करंट की वैल्यू सर सेम ही रहेगी सर?
करंट वैल्यू सेम, करंट तो फ्लो होगा ही नहीं ना अब तो, ये ओपन
नहीं
हो
नहीं
गया
सर,
सर्किट।
पहले वाले केस में सर, पहले वाले केस में।
पहले के केस में करंट क्यों चेंज होगा? जब वोल्टेज या कुछ ड्रॉप 0 है, जो करंट आएगा सीधा सीधा यही यही फ्लो हो जाएगा। करंट निकाल लो। वी वी
डायोड में तो
है।
एसी
डायोड में
करंट।
थोड़ी करंट का लॉस होता है। डायोड के अंदर तो वोल्टेज ड्रॉप होगा ना, करंट तो जो आएगा।
अच्छा अच्छा, ओके सर।
ठीक है। सो दिस इज योर half wave rectifier. Okay, so the output, how can you write the output of output? How can you write? So output you can write, the output of this equation you can write, so V naught is equal to Vm sine omega t. Okay, when t is omega t is, or t is between t to t by 2, or omega t is 0 to pi by 2, 0 to pi. Okay, and now because omega is what? Omega is 2 pi by t. Omega is 2 pi by t. And whenever time period goes from t by 2 to t, then your output will be 0. For this case, this output is 0. Now I want to calculate what? I want to calculate the average value of output. Okay, so average value is defined as a full cycle 0 to t ft dt. Any periodic function, you can calculate the output in this way, time period. Okay, now you know this is 1 by t. You can break it as a 0 to t by 2, or you can write 1 by t 0 to t by 2. Ft is your Vm sine omega t. And for t by 2 to t, this is your 0, so 0 dt. So now this will become 1 upon t, 0 to t by 2, Vm upon t, sine omega t dt. Solve this one and tell me what is the value of average value or DC value of output. Because if you measure, you put a DC multimeter here and the output is coming AC, so it will measure only DC value. Okay, so V average is basically, V output is basically the V naught DC value with DC multimeter, DC value. So now if I calculate the average value or DC value, how much will come? V naught equals to Vm upon T, sine omega t will come minus cos omega t, 0 to t by 2, Vm by t, minus I can interchange the limit. So this will be cos omega t upon omega, omega t upon omega, 0 to t by 2. Okay, this is Vm upon t omega, cos omega t 0 is 1, and cos omega I can write 2 pi by t into t by 2. So this is cancelled. So cos pi, so this is Vm t, and this is 2 pi by t, and is 1 minus minus 1. Cos pi is minus 1. So this become Vm upon 2 pi into 2, that is Vm upon pi. So this is the average value of output, Vm upon pi. So this is a simple circuit of rectifier which you have encountered many times. Now let me discuss, let me first put the board correctly. Okay. The next is your full wave rectifier. Is there any question here?
Yes, sir.
हाँ पूछिए.
No, sir. सब ठीक है.
हाँ. Now full wave rectifier. Next is your full wave rectifier. I am discussing bridge rectifier. Okay. Full wave rectifier, bridge type, bridge rectifier, bridge rectifier. So say I have diodes are connected. Okay. In the form of bridge. Okay. सही से नहीं बना क्या? Just let me थोड़ा सा उसको थोड़ा सा सही करना पड़ेगा. This is your here. Now this is your diode. Okay, so this is the bridge type of rectifier. And now I'm applying AC here. I'm supplying source here. AC V input I'm applying here. And V input is your Vm sine omega t. Okay. And it's coming back from here, this portion. And here one resistor is there, RL. And now I am measuring the output here. I am measuring output like this, V naught. I say this is my diode D1, this is diode D2, this is diode D3, and now this diode D4. Now for positive cycle, what will happen for positive cycle? For positive cycle of input of input, okay, what will become? This will part positive cycle. This part is positive. This is negative. This is your ground. This potential is 0. Now for positive cycle, what will become? Diode. Which diode will be conducting? Tell me which diode will be conducting. For positive cycle, here positive, okay, this positive, so this plate is positive, okay, this plate is positive, so D2 is positive, so D2 is forward bias, D2 is forward bias, so and D3 and D2 is forward bias, D3 is reverse bias, okay, so current this part will be open and this part will be short circuited, this will be short circuited, so current will come like this, will go here, here it is open, D3 is open, D3 is open, so current cannot go, so current will go here and it will go like this. Again, this is the positive negative and then this is the positive negative, so this is also a positive, so this will become short circuit, so current will go here and it will go to the minus, because current is starting from source, it should come back to the source. So the path will be like this. This is the path. Current is coming like this and is going like this and then coming here and then going here. So D2 and D2 is forward. D2 and D4 are forward. D2 and D4 are forward bias. Okay, that is short circuit. Replace it by short circuit. And remaining your D3 and D1 and D3 are reverse bias. Make it open circuit or open terminal, open. And the V output will be what? V output will be, because here is no voltage drop, so this voltage is coming here, and again here no voltage drop. These are open, no voltage drop here, no current is going here. Okay, so what will become? So all the voltage, okay, all the voltage getting drop across the RL. So my VM will be VM sine omega t. Okay, and now what happens for negative? So this is for 0 to t by 2 cycle when this is forward bias, and for negative cycle of input, what will become? Tell me what will become negative cycle? Negative cycle, this part will become positive, this will become minus, this will be ground, this will be ground, and this will be plus. So current will come now from here, opposite polarity. So current will come here. Okay, this is plus, so this will become open. Current will go, this will become short circuit. Okay, this plus, because this voltage will come as it is without drop here. So this become open. And now current again, current is following same path. Current, I am measuring voltage like this, current is also coming in the same direction. So my voltage output sign will not change. So current will go here, 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 here. This is plus, and this is negative. This is short circuit. Current will go from here. Now current will come from here. Okay, it will not go here, it will go here, it will go here, and now again come back and pass from here and come back to the here battery again, source. But the sign, the current direction is same. Positive cycle also my current is going like this, negative cycle also my current is going like this. So my output is same. Here drop is always positive, drop sign will not change. So my V output will be again Vm sine omega t. okay, between t by 2 to t and t. But the problem is there, t by 2 to t sign is negative. Okay, so I have to put a sign here, v not equal to minus sign here. Okay, what does this mean? So for negative cycle, my d2 and d4 are reverse bias, and d1 and d3 are forward bias. Now because my output is positive, but the time period, if you see t by 2 to t, sign is negative, but my output is positive, so I am putting a minus sign. Okay, so you can understand this in a way. Let me write now. Let me draw first the output. So say this is my input. This is a sine wave. This is the sine wave for the whole whole period. Okay, from 0 to t. Now, if I replace, now my output is what? My output is same like this one. And when this is changes sign, input changes sign, my output doesn't change the sign. My output is again, because same direction. Current is flowing, register is like this. Earlier current also coming like this, so I'm using like this. Second time current also coming like this. So my output is in same direction. So I get what? I get the same direction, output in the same direction. So this is my full wave rectifier. Now I want to write this output. Now I want to write this output. So how can I write this output? So if I want to write this output in the form of equation or function, so this is not a sine wave, no? Is this a sine wave?
No, sir.
No.
So this output is what? Output will be Vm sine omega t for the time period of 0 to t by 2 up to here, pi. Okay, time period 0 to, or you can write it in the form omega t also. So when t is from 0 to t by 2, then this is like a same sine wave, but here it is opposite of sine wave, even though it is positive, but this is not a sine wave. So you cannot write Vm sine omega t here into t by 2 to t into t. This is not a Vm sine omega t. Vm sine omega t is this one in this period. This is opposite of this one. So I'll put a minus sign. This is my output. Tell me if this is not clear. This point is not clear. Are you getting what I'm saying here? So whenever this kind of comes, this is not a sine wave. If my output comes like this only, then it is sine. Then it is a sine omega t throughout the time period, both the intervals. But now it is not same for both the intervals. It's different for both the intervals. Here is a positive. Here is sine omega t, and this is the minus of this one, minus sine omega t. So I put minus sine omega t for this time period. Okay. Now again, you want to find the average value. Calculate the average value. How much will come? Find the average value. So if you want to find the average value, so average value, that will be 0 to t, 1t, ft, dt, 1t, 0 to t by 2. My ft is Vm sine omega t dt, and for 1 by t t by 2t. This is minus Vm sine omega t dt. So now solve this one. So this is Vm by t. This we have already solved. This factor we have already solved. How much the value was there? Vm by pi. Okay, so I'm directly because this is we already solved. This is Vm by pi. Just solve this one. How much it will come? So this is minus Vm upon t. Okay, this will be cos omega t upon omega minus t by 2 to t. This is Vm upon pi minus Vm t, and this is 2 pi omega. I'm writing 2 pi by t upon 2 pi. I am putting minus here. I'm taking limit cos 2 omega t by 2 minus cos omega cos 2 pi by t into t. Vm upon pi. Now this is how much? Tell me. T cos pi minus 1 and cos 2 pi, this is plus 1, this is minus 1. So Vm upon pi, this will be 2, sorry, 2 is there. So this is also 2 to cancel, minus plus. So this is also Vm by pi. So this will become 2 Vm by pi. That's for average value for full wave rectifier. Now let us discuss some problems, okay, based on this rectifier applications. This is a for after full wave rectifier, you know, understood. Now some circuits, some problems came in the exam based on this same learning, okay, and now we'll solve those problems. Let us discuss one by one. Are you comfortable with this calculation, these simple calculations? Okay, how to find the average value, you all of you now understood. So anyway, this is average value you might have done in your schools also. So now some problems, let us understand the problem. V input is Vm sine omega t. Okay, you have a diode here connected here, and parallel to this diode, one resistance is there, Rs. Here, one resistance is RL, and here, now you want to measure that DC output value. Okay, here a DC meter is kept which can measure only DC value. So what is the average value of V naught? Find the average value of V naught, and you have been given that Rs is equal to RL. Both values are same, and now you want to find what is the V output here. Okay, so tell me how to do. So for first for positive cycle, what is the V naught, and for negative cycle, what is the V naught? You tell me. Okay, so say if my V input is like this, this is my V input, So positive cycle, what is the value of V output? Tell me. By seeing these both are the same. So for positive cycle, diode is forward bias or reverse bias?
सर फॉरवर्ड बाइल
तो शॉर्ट हो
forward
जाएगा,
bias.
शॉर्ट हो जाएगा सर.
शॉर्ट हो जाएगा. तो करंट कहाँ से जाएगा? यहाँ से जाएगा
सर
कि यहाँ से
आरएल
जाएगा?
से, आरएल के थ्रू जाएगा.
और यहाँ RS में करंट जाएगा कि नहीं जाएगा? RS में.
नहीं जाएगा, नहीं जाएगा सर.
Very good. So now once this becomes short, so current will not go through here because this is the resistance. So all the current will pass through here. So whatever voltage is there, that will appear same like here. Will appear like here, same voltage with Vm. This is a Vm. So this will be Vm. For negative cycle, what will happen? For negative cycle, this is a positive cycle. For negative cycle, what will happen? Tell me, Yoshita. Negative cycle, this part is positive and this part is negative. So diode is open or short circuit?
Open circuit.
Open circuit. So diode is open circuit. Now current will go from which path?
Current will go through RL and RS.
RS. So both are equal.
Yeah. Yes.
So
sir.
yeah. So here voltage will be how much? Here current is going like this.
सर
So here
हाफ.
half. With positive sign or negative sign? With positive sign or negative sign? Output now.
सर नेगेटिव साइन.
Negative sign. Why? Because now I am measuring this one, but now this is a higher potential. Because current is moving like this,
यस
higher
सर.
to lower potential, and I am measuring this one. So whatever I will get that opposite of what I got here. Okay, that means same direction. This one, I got this. This is my V naught positive. Okay, now I'll get opposite of this one. That means the same direction here, and now this will be my like this, same negative. Okay, because current already I have made the negative. Current I already made the negative. Okay, so my output is also in this direction, negative direction only. Okay, and the value is now here Vm by 2. Okay, so I can write my V naught is equal to Vm sine omega t for 0 to t by 2, and my V naught is minus Vm by, not minus. Now this is a sine wave or this is a sine wave or is this sine wave or not?
यस सर.
It is sine wave, still sine wave. So I can write same plus, no minus, Vm sine omega t. Only amplitude changed. This is a sine wave only. So I no need to put minus here. You have to see the wave, and this will come t by 2 to t to t. Tell me the average value. I am representing this wave in the form of function. Okay, intervals, different intervals. Tell me the average value of output. And now you know how to find the average value. So average value will be what?
सर 3 Vm upon 2 pi.
Huh?
सर 3 Vm upon 2 pi.
नहीं, check करो. So V average will be what? 1 by T ft dt 1 by T 0 to T by 2 Vm sine omega t dt plus 1 by T by 2 T Vm by 2 sine omega t dt. Okay, this is the function, and this is the half rectifier we already know. If I solve this one, I'll get Vm by pi. Okay, here something will change. Now I have 1 by T Vm by 2 If I, this will be cos omega t by 2 t. So Vm by pi plus Vm by 2 1 by t. This is t upon 2 pi. Okay. And cos omega t minus is there. So minus I'll put first. So cos 2 pi t into t by 2 minus cos 2 pi by t into t. So this will come Vm upon pi plus Vm upon 4 pi. Now this is -1 and -1. So Vm upon pi, and this will come minus Vm upon 2 pi. Okay. Yes or no? Now how much will come? Tell me. What is the value? Oh, I have done a mistake. Let me check. So it will come Vm upon 2 pi. It will come Vm upon 2 pi is the answer. Tej Kumar,
Yes, sir.
Siali, is that okay?
Yes, sir.
Saravanti, are you comfortable with this one?
Yes, sir.
Okay.
Yes, sir.
So this is Vm by 2 pi. Now let us do some more problem on based on this one. Say I have here a V input. Okay. A V input here. Here I have a diode. Here I have a resistor. Here also I have a resistor. Here also I have a resistor. Now same concept is same like a rectifier. Okay. And now here you have a resistor. So say this diode D1, this diode D2. The value is given 10 kilo ohm, 10 kilo ohm, and 20 kilo ohm. Okay. Now tell me what will happen for positive cycle. For positive cycle, which diode is forward bias and which diode is reverse bias? Tell me.
So D1 is forward biased.
D1 is forward bias. D1 is forward bias and D2 is reverse bias. That means this is short circuit, this is the open, this is the open, and this is the short circuit. Okay. So now my circuit become like equivalent circuit become for forward bias. For positive cycle, my circuit will become like this. Say this is short circuit. So this point current will come from here and current will go here. Now my circuit is basically like this now. This becomes short circuit. So my current will go like this. Okay. And current will go like this. Yes or no?
Yes, sir.
Here it is open. So I can, this is open. So I can directly, this point is this point same. So I can directly say my circuit is like this. Yes or no? So this is 10 kilo ohm. This becomes simple circuit. 10 kilo ohm. 20 kilo ohm and 10 kilo ohm. Okay, this for positive cycle. For positive cycle, this is my equivalent circuit. Okay. Now I want to find the output. I want to find the output here. Question they are asking, what is the average value output here? Okay. This and sorry, sign is changed. I want to measure voltage here. That means I want to find my output is this is my RL. I want to measure what is V output here. So how can I find? Tell me. How can I find? Tell me how to find. And here Vm value also given. V input is given 6 pi sine omega t. Vm value is given 6 pi. Okay. So now my V input is 6 pi sine omega t. So when I'm positive cycle, what is the value of this one? How to approach? Tell me. कैसे निकालेंगे बताओ? Anyone tell me how to find out? Deepak, Tej, कैसे निकालेंगे बताओ? How to find? Leo is there.
सर केवीएल लगा सकते हैं.
KVL लगा सकते हैं. So this voltage is equal to this voltage, and this voltage is equal to across these two resistors. Either you apply current division, and find the current here, then find the voltage here, or directly you can say this 6 pi sine omega t is here and across this one, and now you can apply voltage division. So my V naught will be what? V naught will be total voltage is 6 pi sine omega t, and this is parallel to what? Parallel to this full circuit. 10 plus 30, 10 plus this is 10 plus 20, that is 30 kilo ohm into I want voltage here 10 kilo ohm. This will be 10 kilo ohm. This cancels out. This cancels out. So how much is coming? 2 pi sine omega t. For positive cycle, that means from 0 to t, t by 2. Is that point clear to everyone?
Yes, sir.
Similarly, find out for negative cycle what will become. Okay. For negative cycle, you tell me what is the value. Amandeep, Shweta, for negative cycle, just tell me what is the value. For negative cycle, D1 is reverse bias and D2 is forward bias, and my voltage coming like this. Okay. Now tell me what is the equivalent circuit.
Sir, current will go through only 20 kilo ohm.
So यहाँ से भी जाएगा ना. Now this is open.
Yes.
This is open. Current will go from here, here, and will come back here. So now equivalent circuit will be what? This is your B, okay. And now this point is open. So this point is not connected here. Directly this point is connected. This point is connected. Okay. This point is connected. So, and current is going what? Current is, say this first I'm drawing, then you can modify later. Okay. So this is my circuit now. Here it is open. Okay. So current is coming like this, and I'm measuring voltage here, V naught. So current is coming, current coming here, here, and then this is combined together. Okay. So you can say if this point is broken, but this point is here, so you can say this is like equivalent to Vm, At least this point is same. So I can draw this resistance like this here, and this is parallel to this resistor. So this I can draw. Sorry, here, and what I can do now, this is here, this resistance, this point is here, and here this point is here. So resistance, this resistance is here, this resistance is here, okay, and this point, but this point should go to directly to the this one, nah? So how should I do? This is open here, this is connected here, so this is okay. Leave it like this only. Okay, tell me now what will happen. Tell me what is V naught here. What is V naught here? Tell me. Find out V naught. I'll come in 1 minute. You find out the V naught. So tell me, what is the output now? What is the output now? So basically, this resistance there across this, across parallel to this one, this resistor is there. Okay, and now if I make
Sir,
it,
voltage is 3 pi sin omega t.
so this point I can stretch. So if I can stretch, okay. So obviously this point is connected here. So I can write this resistance is like this. Is the same like this one. This resistance is same like this one. Okay. So this is now I'm measuring V naught here. This is V naught, 10 kilo ohm. This is also 10 kilo ohm. And this is your 20 kilo ohm. Okay. Is that fine to every? Okay. And current is coming now here, here, here. So current is also I'm again the same direction. V naught is direction is not changed here, and this combined will come here. And now this V input is across this one and this one. So I can write my V naught will be 6 pi sine omega t divided by now this 20 kilo ohm into 10 kilo ohm. Okay. So this will give me how 3 pi. So this will come now 3 pi sine omega t without changing the direction. T by 2 t t. Tell me it is coming or not, students?
Yes, sir.
बाकी लोग बताओ. साइन है, साइन चेंज और नॉट? साइन तो चेंज हुआ नहीं ना, कि हुआ था साइन चेंज? साइन चेंज नहीं हुआ था. ओके, बट साइन चेंज नहीं होता एक्चुअल में, फंक्शन में चेंज हुआ था. दैट विल सी. सो नाउ व्हाट विल सी, the earlier also current is coming moving from, when I positive cycle current was moving, this was short circuit current was moving from here to here, and now also current is going from here to here. That means this is a full wave rectifier, and full wave rectifier we put always minus, because now what is happening, this is your input. V input is coming like this, 6 pi sine omega t, 6 pi. Now positive cycle, you're getting 2 pi sine omega t, positive direction. Voltage is positive, current is also positive. I'm getting 2 pi. And now what is happening? For negative cycle, I am also getting same direction, but with a amplitude of 3 pi. Yes or no? So here I have to put the minus sign. Okay, now tell me what is the average value. So this point should be clear. Don't do the mistake in the exam. That's why I'm doing more problems. Same rectifier problem. You should understand how to write. So direction doesn't change. That means like if I say this is here, second time also I'm getting same current with a different amplitude, but in the function form you have to put the minus because this is not a sine curve. Okay. Shekhar, is that point clear?
Sir.
Now find the average value. Average value will be 1 by t ft dt 0 to t. Okay. So 1 by t 0 to t. Okay. 2 pi sine omega t by 2. Okay. dt plus 1 by t by 2t minus 3 pi sine omega t dt, and this we have already solved. Vm by pi, Vm is 2 pi, so 2 pi by pi, you can solve and check it. Okay, and for this also we have solved. What is the value comes from here for full wave rectifier? This also comes to Vm by pi. Now Vm is minus 3 pi, so minus 3 pi by pi, yes or no? Plus minus minus plus, minus minus become plus. So full wave rectifier, this value is also Vm by pi, this value also Vm by pi. That's why we get 2 Vm by pi. You can solve it. Okay. So this will come 3 pi by pi, and now this pi cancel. The average value is 5. Have you understood this one? Okay. Tell me, Amardeep, you can solve and tell me is coming or not.
Yes, sir.
So this will be 5 volts. Okay. These are all volts. So this was your, I'll give some homework questions also. So this was your rectifier, half wave rectifier. Okay. So you understood how to do rectifier problem. Now let me go back to the constant. Now we have done ideal diode model. Okay. Now we'll do constant drop, constant voltage drop model. Voltage drop model. Okay. How to treat when you have a constant voltage drop model. So constant drop voltage model says this is pi, this is minus. Okay. And now I want to replace this diode. So constant voltage drop model says whenever diode is forward bias, okay, and if it's a silicon diode, and your V and the open circuit voltage, okay, open circuit voltage is greater than, across the diode is greater than, you measure the open circuit voltage, if open circuit voltage across diode is greater than 0.7 volt, if the open circuit voltage across the diode is greater than 0.7 volt, you can replace this diode by a 0.7 volt battery. This is, you can replace by it by a 0.7 volt battery. Okay. But for forward bias, the condition is the open circuit voltage across the diode should be greater than 0.7. And similarly, if your diode is reverse bias, okay. So if forward bias and open circuit voltage is less than 0.7, if open circuit voltage is across diode, open circuit voltage across diode. If it is less than 0.7 volt, then diode remains open. Then diode remains open. So you have to replace by open. And here, if it is reverse bias, so reverse bias, you have to make diode as an open circuit. Okay. So reverse bias, diode is always open. Diode is always open. Okay. And forward bias, you can replace positive plate by positive. You can replace by 0.7 volt battery, but the condition is upward voltage coming here, output open terminal should be greater than 0.7 volt. Then only you can make it battery. Otherwise, diode will be cut off. Okay, cut off means no current can flow if the voltage across the open terminal is less than 0.7. So you have to treat like a reverse bias only. Okay, that is the things. Okay, so you have a say you say this is your IV characteristics. Okay. So if your voltage is less than this one, so no current can flow. If voltage is less than this one, no current can flow. That is open circuit. Okay. Here current is very negligible. So here also it is open circuit. So basically now constant voltage drop model says क्या बोलता है? Have you written this one? So I will rub this one. So constant voltage drop model का मतलब है that says that if you have
Sir, this is particularly for silicon only.
particular silicon only.
Okay, sir.
So for silicon, this is the actual curve. This is the actual curve. But this model says because this is the sharp increase the current, so he says voltage is not varying, voltage is constant. So this is for silicon. For silicon, the voltage is 0.7 volt, and for germanium, the voltage will be 0.3. 0.3 volt, 0.7 volt, and reverse bias, both are open. Zero current, so both are open. Okay, so the curve are approximated. Okay, let us understand with some examples. Say I have a 5 volt battery. 5 volt battery. Here I have a resistance of 1 kilo ohm. Okay. And this is the silicon diode. Okay. Diodes. Silicon diode now. Silicon diode. You tell me what is V naught, VD, VR. Tell me what is the value. Find the open circuit voltage, whether it is forward bias or reverse bias. Diode is forward bias or reverse bias? Tell me.
Forward bias.
Forward bias. So if I open this one, understand how to, if I open this one, no current is flowing. That means no drop is there. That means this 5 volt is coming here. That is open circuit voltage 5 greater than 0.7. So this diode is forward bias, and whenever it is forward bias, you can replace it by a battery. 0.7 volt. Okay. Now tell me what is V naught? What is V naught? 0.7 volt. What is VD is equal to V naught? This is also equal to VD. I want VR, V reference, 5 minus 0.7, 4.3 volt. What is current flowing here? I or ID, the same thing. Same here, current is 0. This current is coming, this current is going down. So I equal to ID equal to how much? 5 minus 0.7, 4.3 is here, divide by 1 kilo ohm. That is 4.3 milliampere I equal to ID. Now this same diode, same circuit, if I replace it by 1 volt, tell me, tell me, now the circuit is like this. Tell me the values. What will happen? Diode is forward bias or reverse bias?
Forward biased.
It's still forward bias. It is still 1 volt coming. So my V output will be again 0.7 volt because it can be replaced by a battery. Okay, and my VR will be how much? 0.3 volt. And my current I will be I equal to ID will be how much? 0.3 volt divided by 1 kilo ohm. How much? 0.3 to 10 raised to power minus 3 ampere. Okay. Now let me modify this one a little bit more. Any question? Because you please ask questions because minimum that minor things you should know how to operate. Okay, then circuit is maybe a little bit difficult. Okay, but you should know the concept should be clear. Now say I am replacing this by say 0.5 volt. Same circuit. Silicon diode. It is open or tell me now. Forward bias or reverse bias?
Reverse
Sir,
bias.
So it is not short circuit. It will be open because this voltage is less than this open circuit voltage is less than this one 0.7. So obviously this will become open. So your V naught, VD will be how much? How much? What is the value of V naught now? What is the value this one? Tell me.
so same ही हो जाएगा सर.
कितना?
0.5 volt.
0.5. Same voltage will come here because no current is flowing. I is 0. I is not flowing here. I is flowing, so no drop is there. This voltage is open circuit voltage 0.5 volt, and I equal to ID equals to 0, and VR which is equal to I into R, that is also 0. Okay, let us do one more problem. Here you have a say 12 volt battery. This is silicon. This is silicon diode. This is germanium diode. Okay, 5.6 kilo ohm. And this is your V naught I am measuring here. Okay, tell me how much current is flowing through the load. Find the I and find the V naught. Okay, tell me what is I and V naught flowing in the circuit.
सर जर्मेनियम का 0.3 वोल्ट कंसीडर करेंगे सर.
Consider करेंगे. So अगर if this path is closed, then the open circuit voltage you have to remove both the diodes, and the voltage should come greater than how much? 0.7 plus 0.3, 1 volt. Open circuit voltage should be greater than greater than equal to 1 volt. Then only current will start. Greater than 1 volt. Then only current will flow. Okay, that you have to keep in mind. So obviously, this is both are forward bias, so I can replace by a battery. So this is 0.7 volt. This is 0.3 volt. Okay, so I can write now this battery K. If we apply KVL here, minus 12 plus 0.7 plus 0.3 plus V naught equals to 0. So V naught will be 12 minus 1 volt, that is 11 volt. Okay, and I will be what? V naught divided by resistance, that is 11 divided by 5.7 kilo ohm. Tell me how much is coming. .96 milliampere. Answer. Let me do it one more problem. Okay. Find the current in 6 kilo ohm. Okay. Number one case, if diode find I, if diode is number one case, silicon, number two, germanium, number three, ideal. Okay, all the three cases find the current here, current in the circuit. Find the value of current. Take first case. So first case is silicon. So what is the open circuit voltage here? Tell me. What is the open circuit voltage? Tamanna? Karishma? What is open circuit voltage across the diode?
Sir, 1.3.
1.3 कैसा आएगा?
2 minus 0.6.
Open circuit voltage across diode. If I make it open, ये वोल्टेज कितना है?
So 0.7 है.
0.7 आ रहा है क्या? चेक करो. So now current cannot go here. 2 volts, 2 and 8. I will be how much? 2 divided by 8 kilo ohm. Okay. So voltage drop across 2 kilo ohm, how much? V open is what? V open is basically V 2 kilo ohm. That is 2
Sir,
upon
it's 0.5.
0.5. Yes, 2 kilo ohm. कितना हो जाएगा? This is 1/4. This is 1/2. 0.5 volt. So if it is a diode is silicon, this will be open or this will be closed. If I place now silicon here, that will be open or that will be closed.
Sir, closed.
Open. Why? Because this voltage is less than 0.7 volt. So if you place now silicon here, this will treat like open circuit, and now the current value will be same like this one. I asked what is I, so I will be what? I will be what? 0.25 into 10 raised to power minus 3. That is 0.25 milliampere. Okay. The first question is the first answer. In the second case, what will happen? Tell me. Second case, if I put germanium here, second case, if I replace by germanium, it will be open or closed?
So now it will be closed.
Close. Close means what?
So current will flow.
Current flow. How much replaced by what? If it is
So
closed,
0.3 volt. 0.3 volt bed.
0.3 volt. Now I have to replace by 0.3 volt. If it is a close, that is the point I'm trying to tell you. Okay, always check what is the open circuit voltage. If open circuit voltage is greater than 0.7 for silicon, it should be the greater than the 0.7 and 0.3. So now it is greater than 0.3 because this open circuit voltage is 0.5 always. So this will be conduct. Silicon will not conduct, but germanium will conduct. And now tell me what is this I? What is I? So if this is 0.3, this is also 0.3. So now I will be what? I will be this total 2 minus 0.2 is this one. Now is KVL here. So minus 2 plus 0.3 and plus here. If I say this here is V naught, suppose here say V naught. So V naught equals to 0. Okay. So V naught will be what? 1.7 volt, and I will be what? I will be 1.7 divided by 6 kilo ohm. How much is coming? Tell me. कितना आएगा? 0.02 milliampere. Check me answer. I don't remember. What is the answer? 0.2 or 0.28, na? It's 1.76 divided by 6. How much will come? 70 divided by 60.
0.28, sir. 0.28.
2.8.
2.28 कहाँ से आएगा? ये 6
Sir,
divided by
0.28 सही है.
0.28 सही है ना?
ठीक है सर. हाँ.
0.28 milliampere. Okay. And so here this is the V output. First case, what is the output here? Current was this one. So V output was first current. Current is this one, 0.25 milliampere into resistance is 6 kilo ohm. 6 kilo ohm. We can cancel out. Okay. So this become how much? 0.25. This is 1.5 volt. And here output is 1.75 volt. Correct? Yes or no?
Yes, sir.
Okay. Now the last is the ideal case. If I replace by ideal, then diode will conduct or not? If this diode is ideal, third case, the ideal diode. So ideal diode will conduct. It will conduct or cut off? Batao. If I replace by ideal diodes, Saravanti, ideal diode will conduct or it will be in cut off operation? Tell me.
Sir, it will conduct.
Conduct means it will be replaced by what? Ideal diode will be replaced by what?
Short circuit. Short circuited.
Short circuit. So now, what is the direction of current? Current will start from here. Whether here
No
any
current. No current.
current, so all current will come here. This current will come here. So current will be only across the 6 kilo ohm. There is this 0 volt here. So no current here. I0. all current will be short circuited. So now the I will be what? I will be 2 volt divided by 6 kilo ohm. That is how much? 1 by 3 into milliampere. That is 0.33 milliampere. Okay. And if you measure the V naught here, that V naught will be how much? 1 by 3 into 10 raised to power minus 3 into 6 kilo ohm. So this will be 2 volt completely. This 2 volt will completely come here. Okay. So let us stop here. And tomorrow we'll continue. Okay. Thank you.
Okay, sir. Thank you, sir.